As promised in the last video, we're going to talk about the new ATEM2PTZ controller, and this one uses a built-in de-embedder that takes the return camera feed from the ATEM and applies all the pan tilt controls through the connector out to the pan and tilt head. And again, here I'm just using a camera, but this time we're using, rather than using the data out of the camera head, we're using the data that comes out of the return feed. So this is a return feed coming in from the ATEM, and it loops out up to the return input to the camera, so we can do all our CCU controls. So it's a return coming in back here. Now this particular unit is very similar to the one I originally showed, which uses the actual data that comes out of the micro studio camera PTZ connector, which plugs into there. Now this one here is, as I said, we're extracting the data out of the return feed, so this can be used with any other camera besides the micro studio camera, where the other cameras don't have that capability of giving you PTZ. Now this interface, not only does it supply discrete data for the cheaper heads, like the Viscas and etc., but it also supplies RS422 for using the more expensive heads. Now this can supply the various protocols, but most importantly it supplies Visca on a RS422. I am actually doing another one which is Visca on Ethernet, but that'll be a little bit off until I get the volume of sales that are going through at the moment with these items. Now this unit is a little bit larger because it's actually got three boards in here rather than the traditional two, and I've got it currently set up here again using my PTZ to ATEM, which I showed in the last video, with just a standard common guard variety controller. And as I come up here and show you the output, as this is me turning, I'm on the wrong camera, maybe I should go to, I'll just go to the other, I've got another camera up here which is here. You can see I'm just doing the panning and tilting on that camera here, and it's just panning and tilting. That camera is, if we just do a cut here, that camera is up here. You can see if as I'm doing that here, you'll see there's the camera panning around and tilting up and down. You see tilts better, tilting down, tilting up. And if I just now go over to, just change over here and just go to 5 camera, and now I'm now controlling that camera using the same controller and doing the tilts. This these controllers, which are designed basically for security companies and such, I've actually there's a function on here called menu that I'm not quite sure what it's supposed to be used in a security, but I'm using this to change speed, so you can actually go between slow speed and fast speed. And I'll just give you an example. This is just me doing a pan, that's full flat stick. Now the pan speed is depending on how far you move the joystick. You can go slow, and then the more you move it, the more you go fast. And then that you can then multiply that. If I just push the menu button, you can see how fast that's panning now. So it's going really fast. So if you need to do a real quick reposition, you just push the menu button once. Now if I push the menu button once again, we now go back to the slower speed. So it's good for having to do a quick reframe or whatever. Now I just want to quickly explain the workflow here, because I've had a few people ask about this. This is the current workflow that I've got here. You can see I've got a PTZ controller, and as I said, that can be any controller. Frame it up maybe first, there you go. So that can be any controller, and it's now talking to the PTZ to ATEM which was this unit here I showed in the last video. That's just taking an RS485 through just a twisted pair coming into the 9-pin connector, and then it's then connected through into the ATEM through a network, through an Ethernet network, and then you can take the output of the ATEM, which is a Visca, and you can feed that into the PTZ interface, PTZ-IF interface, or in what I'm doing here is that I'm just actually embedding it through here as camera return, and then the camera return is coming back into this box that I just showed you here. The yellow button indicates that it's a de-embedder rather than just taking the Visca protocol out of the Micro Studio camera, and then it's then connecting through to any PTZ head. And as I said, you can either use the discrete output from the box, or you can use the Visca that comes out of the connector as well. And then you just then plop your camera on that. So in here, in this example here, I'm showing a Ursa broadcast. So you'd take your return feed out of your controller, because this will be sitting at your camera head, and you take the feed and then you go into do all your CCU control. Now this box obviously is getting fed from the camera return. The camera return can be either a coax, or in my situations that's coming back on a fibre. So we're coming out of the ATEM into a fibre converter, and then coming down into a fibre converter here again, and then doing all the business. And as you can see, there's 2 cameras here, but you can have as many cameras as the ATEM will let you. So if you've got 20 cameras, all with controllers and pan and tilt heads, you can actually control them all from this one box by just say you go camera 20, you just go 20 camera, and now that's camera 20. And if I actually go to, I'll see if I can do it. I can't. That's right. This mixer has only got 16 inputs. So if I just go say 15 camera, and I can just hit aux, which was selected on the aux bus. So if I go over here, you can see over here, oh, I can't get my camera around there. You can see it's selected camera 15, and I'll just do the same thing again here. So if I just go camera 11 camera, and then I hit the aux, you see there it is, it's now selected that, whatever input 11 is on here. So basically I'll just put that back to camera, because this particular camera I'm controlling here is camera 5, so I'm going to go 5 camera, and then you can see up here, and again we have the ability to be able to do, let's say, zoom and wide. See, that's me hitting the there you go, that's me hitting the wide button, it's telephoto, but that's all part of this arrangement here. And we can then do a zoom in, and you've got all the other peripheral stuff like focus. It's hard doing showing focus when you've got a camera pointing at a monitor. There you go, that's me pushing the focus in and out. And we also have what's the other one? Iris, close and iris. So it's just close, dropping the iris. So you've got all those controls on here as well. So before I sign off, I just wanted to explain this particular setup, as I mentioned, is what I'm using here at the moment. And the key feature is these units here, which extract the PTZ out of the camera, out of the ATEM's camera return. Something else you probably may not have noticed, or you may have noticed. This has also got tally on it, so let me just, if I just go over, if I can show both of them, you can see it's got a green, a red, and if I switch it on, just take it off program, you see it's got a green, well, it's got no tally because there's nothing on there. If I go over here and just select it on preview row, you see there it is on preview, and if I just cut between the two, see it's switching between program and preview row. So that's an extra little feature. You can have built-in tally as well. So I just wanted to then just show you this other workflow, and this is a bit similar, except the difference here is we're using micro studio cameras which have the built-in PTZ, so you can see the return feed is coming into the micro studio camera, and then the micro studio has the RS422 Visca out on its connector going into the PTZ IF, which is the unit I showed in my original video, which is the similar, but it doesn't have the built-in de-embedder, and then it then goes and controls the camera head. So you can see you've got multiple setups of that as well. So that's it. That's the third unit in the PTZ range, and I will be working on a new surprise product very shortly.